So I would love to know about your path into STEM. Like, when did you first know that you were kind of excited about technology and things and electronics, and how did you get into it? And you have like a master's in theoretical physics, is
I
that right?
do. I do,
Yeah. So how
yeah.
did you get from there to like, which is very abstract,
Mhm,
to actually making real world things with your hands, and which is very not abstract.
mhm. Definitely. Well, it's weird because my journey into STEM started like in quite a traditional way, just in a like doing a pure science degree thing. And I super enjoyed it. But then like when I finished my master's, I was kind of thinking, well, where do I go now? And it's like quite common maybe to do a PhD afterwards, but I didn't find that like one little vein of science that was like my niche, the thing that like I really felt like I could commit myself to for like 3 years because there was just I'm too much of a magpie. There are too many things that grab my attention. There was no way I could settle down and do one area of science for 3 years. So I was like, well,
Yeah.
what do I
What
do now?
what were you studying in theoretical physics? Like, what drew you to that course of study?
Well, I got really into particle physics when I was younger. I
Mm.
think because I was kind of growing up around the time of like the LHC and the Large Hadron Collider came
Yeah.
online, like when I was kind of sixth form. So it was just kind of like just when I was getting to like the really exciting science in school, there was a big like real world thing that was science in action, and I kind of wanted to be a part of it. And
You're
I
like,
love
"I'm gonna
telling the
solve
story.
gravity."
Yeah, and I love telling the story that like I was nearly technically sort of a co-discoverer of the Higgs boson.
What? Oh my
Um,
god,
but
that
I
is
think that
super
the
cool.
story of saying
I now
that I
want
was
your
like
autograph for
almost, yeah,
sure.
I'll stick with the post. But the story of like being almost a
Yeah.
co-discoverer of the Higgs boson is actually just as good as being like a co-discoverer of the Higgs boson. So when I was doing my masters,
Mhm,
one of the projects that we could kind of choose to do
mhm,
was doing background calculations for the LHC. Because of course, to know that you've got a signal, you need to know what background you're expecting to be able to subtract that off and see your signal.
mhm.
But it turns out that these background calculations, you need like tons and tons and tons of them, and they're actually really tedious to do. So they were just getting loads and loads of master's students to do these calculations,
Oh my god.
like so that they'd get their names on the papers, like having contributed research that had helped to discover the Higgs boson. But in return, they had to do like a year of some of the most boring calculations. So I was like on the fence, like, oh, wouldn't it be great to be able to say I was a co-discoverer of the Higgs boson? But
Mm.
then I realized that the story of saying I was nearly a co-discoverer of the Higgs boson is just as good, but I don't have to do any of the boring calculations.
Like, I could have been, but it was just too boring for
I
me.
just chose not to. Yeah.
I like it. I like it. That's
Yeah.
awesome. So you were like, "Yeah, this is too boring. I need to put together some cool electronics."
Well, for my masters, I did it was like solid state physics. I was like researching thin films of helium I did on a graphite substrate to see if they go superfluid, but
Oh,
only theoretically. I didn't touch anything practical. In fact, I switched to the theoretical degree because I did some practical labs lower down in my undergrad and I was so bad at them. I was actually a danger to myself and other people in the lab. So I switched onto the theoretical degree.
oh,
And
that's
now I've just sort of like come full circle back to making physical things and kind of doing the practical aspect much later. But I'm pleased to report I'm a lot safer at it now than I was back then. But I remember this one particular lab that we had that we were meant to just be doing an experiment to calculate the Earth's magnetic field. And I managed to get it so wrong that I was out by 2 orders of magnitude. If the Earth's magnetic field was actually that strong, all the iron would be pulled out of your blood.
nice.
So,
That totally reminds me of a lab that we did in undergrad. It was the infamous bucket lab.
uh-huh.
And, like, all engineers had to go through this one course, and it was like a lab course in a whole bunch of different disciplines.
Uh-huh.
And there was this bucket lab where the general problem was you had a bucket, like, with water filled up to a certain level,
Mhm.
suspended on a string, and you had a sign for, like, a storefront on this string, and you had to calculate the level of water needed in the bucket so that when you twisted it, it would like rotate and change at once per second. I think it was at like
Ah,
1
okay.
hertz
So
or
you get
one
the
and a half
right
hertz.
frequency of, yeah.
Yeah, because, storefront owners, this is a totally common way to put a sign out, and but like you didn't have exactly the bucket in the store, so you had to sort of model it and then perform your
Mm-hmm.
experiments in the lab and then extrapolate it onto the actual bucket and all of that stuff. And I'm pretty sure the amount of water in our bucket was light years. And
That is
people
excellent.
it was like nobody knew what the right answer was, and it
Yeah.
was like it was this lab that absolutely kind of was like the lab with the story
Hmm.
that every year you heard about it before you took this course, and it was like the bucket lab, and
You're
people
looking
got like
forward to your
nanometers of
experience.
water, I'm pretty sure, all the way up to like light years like we did. So, yeah.
Well, I think it's better to be over prepared. So like having more water than you needed, even if it's like a couple of galaxies worth, is like
Right? Right? I
definitely the
mean,
right way to go.
it's a good resource. It's a good
Yeah.
resource.
Yeah.
Oh, that's hilarious. So, okay, so how did you very first get into STEM? Just like in was it like in high school before that? Did you always kind of play with, toys that were a little geeky and nerdy and
Yeah, I think definitely.
yeah.
Yeah, just a nerd from the start.
Yeah,
Yeah, I mean, like everybody loves Lego, but
definitely.
all of those kind of like kits. I remember distinctly now, and it's like a memory that I'd forgotten for a really long time, and now kind of recently, since getting into electronics more specifically, I remember getting Real Robots magazine when I was a kid, and it was
Mm,
like I used to absolutely love it, and you don't see so many of these now because I guess print media with like the internet is kind of not what it used to be in
yeah.
terms of popularity, but it was a magazine, and every week you got another little piece of your robot that you
Ooh.
would add on, and there'd be like a couple of pages how to plug it in, like which bits to connect. It was all
Wow.
really simple, just kind of like JST connectors or something to kind of plug all the boards in together, and just like a couple of screws and standoffs. But like
Yeah.
you built over weeks this robot that went from just being a thing that blinked a couple of lights to it can follow a line. And then in like season 5 or something, you got to make like a remote control and you could drive your robot around. And like the
Ooh,
idea that you built that was just
that's super
like
cool.
mind blowing. Yeah. And I absolutely adored that. And it was so funny because I just kind of remember like looking at those circuit boards and thinking that's like actual magic.
Yeah.
Like this thing has a brain, like it can do stuff, and this tiny little square with like these just anonymous bits of metal on is making it do that, and wanting to know kind of how all that worked. And then I
Well,
kind of don't know where I sort of fell out of love with it, and now I've come all the way back to it,
that's
and it's a
awesome.
nice feeling.
That is super awesome. So, okay, so then you're in school and you have a master's degree, and what kind of propelled you into playing in the realm of the physical again?
Well, I started working for New Scientist magazine pretty much straight out of uni. I had no idea what I wanted to do. It had to be something STEM related, but
Yeah.
beyond that, I had no idea. I remember going to like a careers fair and being just so lost and not knowing what I wanted to do, that I just decided I was going to work for whoever gave me the best freebies. And I came away from there and I looked at my bag and I went, I actually don't think the atomic weapons establishment is me.
Yeah.
Maybe this was a bad strategy. Maybe I'll have to try and look for a proper job in a more traditional way.
Yeah.
And I just got really lucky. New Scientists were like advertising for like an intern just when I was kind of searching for something. And I applied and I got in, and I'd spent 5 beautiful years being a sort of editor and sort of general dog's body. But
Nice.
I kind of had this idea that the maker movement was happening. People in their bedrooms were making these cool things with technology. And as a science and technology magazine, shouldn't that be something that we're covering? So I started asking around and saying, like, why isn't this something that we're talking about? Why aren't we writing anything about it? And eventually they said, well, if you think it's so good, why don't you write about it? And at the time, I just kind of knew it was a thing, but
Yeah.
I was nowhere near it. I didn't have a 3D printer. I didn't know how any of it worked. I'd heard of an Arduino, but I'd never like bought one or used one. And they were like, "Why don't you write about it?" So I started writing about it, and I thought, actually, I'm going to have to kind of get involved to kind of know what it's about. So I bought an Arduino and I made a little project and thought, well, actually, that was quite cool. And everyone seemed to enjoy that. So then it grew into this column where every week I'd make like a daft invention and write about it. And over time, I just realized that I liked the coming up with the ideas and making the dumb thing more than I enjoyed like the writing about it and the rest of like my day job. So I was kind of like, I wonder if I can just make that the whole job instead of having to do these other bits.